The double angle formulas, these are not, again, these are ones that would be provided, that will be provided, and in fact, let me do this now before, so I don't forget at the end. This is the sheet of formulas that you will be given when we take our test. So these are not formulas that you need to memorize, but we do need to, identify times, places when we can use them and then use them effectively. We've got a formula for sine, a formula for tangent, and then you'll notice there's 3 versions of the formula for cosine. Now, they're all related to each other. In fact, starting from any of these double angle formulas for cosine, just by using the Pythagorean identity, the fact that sine squared plus cosine squared is equal to 1, you can, get in between these 3 versions for the cosine. We call them double angle formulas because the angles are different, and in fact they tell us how to get the sine or cosine or tangent of twice an angle if we know values for the, just plain old theta. So for our first example, let's say we want to simplify. They're not asking us to prove anything, but just simplify this expression. Now there's more than one way we could start. One of the first things I like to do is just make sure I'm absolutely clear on what's the argument, what lives inside the function. It's not cosine squared of 2 and then times x, right? The 2x lives inside that cosine squared, likewise with the sine squared. The fastest way to use this is probably just to make use of this first version of the double angle formula for cosine. And in this expression, theta would be played by 2x. So if we're going to use the double angle formula, we'd be using it in this direction, the right to left direction. What would this look like? Tapan.
Thank you. Sine of 2x?
Not exactly.
4x.
Yeah, so it'd be cosine of twice the angle, right? So whatever this angle is, we're going to double it, and of course that's 4x. Let's try another. This is a prove that type of problem. Now, the first thing that I notice when I look at a problem like this is that these arguments inside the trig functions are different, and that's really important. We're trying to show that 2 divided by 1 plus cosine of 2x is equal to secant squared of x. And that's actually a hint that I'm going to try to use a formula that'll somehow transform my function into one that takes 2x as an argument to just one that takes x as an argument. And we can do that with the double angle formula. So we might start by using a double angle formula for cosine. And the big question is, well, which one? Now, you could use either one and eventually get to the same spot, but let's think about where we want to go. We want to go, our result should just be secant squared. What is secant? How do we define the secant function? 1 over cosine. So I want to show that it's 1 over cosine squared. So when I go up to pick an identity to use, I think it makes the most sense to use this one, the version of the double angle for cosine that only allows us to write it in terms of the cosine function, not the sine function or both of them. So let's say We begin there. So 2 divided by 1 plus cosine of 2x. I'm just going to replace the cosine of 2x with 2 cosine squared x minus 1. This is the double angle formula. At work. What can we do now?
Could we combine the terms?
Mm-hmm. What would we end up with?
2 over 2 cosine squared x.
Great. Now what? Cancel the 2's, yeah. Right, we're now it's all over but the shouting. We've got 1 over cosine squared x. And what's 1 over cosine squared x equal to? Secant, yeah. Secant squared x. So far, so good? Okay. All right, let's do another one. This says, oh, it's a nice word problem. To find the area of a right triangular piece of land, we can use this formula, where C is the hypotenuse and theta is either of the 2 acute angles. So it doesn't matter which one we know. Let's derive this formula. I mean, show that this formula is true. Okay. So here's a nice right triangle. And let's say I'll just use this angle here, call that theta. It'll work either way, though. Label our sides, A, B, and C. Of course, C has to be the hypotenuse. We want to find the area of this right triangle. We want to show that the area is equal to this formula up here. But we're starting with a right triangle. What is the area? How do we usually find the area of a triangle? Yeah, right. The 1/2 base height. So So in this case, 1/2 times AB. Got a little work to do. We're not quite where we want to be. But we have a right triangle, and when we've got a right triangle and an angle, SOHCAHTOA cannot be far behind. So what we could do is get an expression for, we want to eliminate, like this formula that we have so far uses the 2 legs. The formula that we want up here does not use A or B at all, right? So we want to get rid of both A and B. So let's use SOHCAHTOA to help us get expressions for both A and B. If we use the sine function, then sine theta is B over C, and that means that B is going to be equal to C times sine theta. Likewise, we can use the cosine function. Cosine theta at C. Adjacent over hypotenuse is A over C. And we could solve this for A, and we get A is equal to C times cosine theta. Okay, we're making progress. We have these expressions for A and B that use only C and theta. So let's substitute them in up here. So we get 1/2 times A is C cosine theta, B is C sine theta. We know we're making progress, even if we're not quite there. We can tell we're making progress because the only variables in this expression are C, the hypotenuse, and theta. which is definitely included as part of our goal. So let's keep going. We have 1/2, we've got 2 factors of c, there's c squared, and then we have sine theta, cosine theta. So look at where we are, look at where we want to go. What's different? What's progress that we still need to make here?
Eliminating cosine.
We want to eliminate cosine,
Maybe 1/4.
and it should be a 1/4. Yep, anything else different?
2 theta.
It's a 2 theta, yeah. We want our formula to involve sine of 2 theta. So now's when I go back and I say, okay, well, maybe there's some identity I can use to help me out. We know that sine 2 theta is 2 sine theta cosine theta. So I'm going to use that and do a little side work. I want to be able to use that somehow. Now, the part that we have in the expression is just the sine theta cosine theta. So in using the identity, we could divide both sides by 2, and we'll find that 1/2 sine 2 theta is equal to sine theta cosine theta. And we can plug that in here. And now there's our 1/4 that appears. So 1/4 c squared times sine 2 theta. Are we having fun? So next time you want to find the area of a triangle, be like, I don't need the legs. Who cares about the legs? I just need the hypotenuse and an acute angle. Okay, let's try another one. This one's fun, just so you know. This one's nice because it allows us to use identities and some algebra to work with this. It's another prove problem, so we're trying to prove that this equation is true. The big thing that I glom onto as soon as I see what I'm trying to do is that the argument on the left side is x and the argument on the right side is 2x, which means that a double angle identity might come in handy. However, the hard part of all of these problems is like, how do I get started? I mean, sometimes there are things that jump out at you or things that seem obvious, like, the first one we did up here, and be like, oh yeah, well that looks exactly like the double angle for cosine, and it was sort of like a one-step problem. It's not always obvious, and when I look at this, I just want to let you know, like, there's nothing immediately that jumps out at me as far as an identity to use. So what could we do?
Distribute the second power.
Are you suggesting that we distribute an exponent over addition?
No, I'm saying multiplying sine x plus cosine x times.
Yes, we should FOIL this out. So let's do it. So let's see, what do we get in the top row?
Sine squared x. Sine cosine x.
Yep, sine x, cosine x. Bottom row.
Sine x cosine.
Cosine squared x.
So we've got two of these guys, right? So 2 sine x cosine x plus cosine squared x. Now what?
Combining sine squared x plus cosine squared x to equal 1.
Yeah, so this right here, we've got a nice Pythagorean identity. We know this is equal to 1. So now we have 1 plus 2 sine x cosine x.
Is that just sine 2
Yeah, because?
2 sine x plus cosine x equals sine 2x?
Yeah, like that. So you're looking at the list of formulas, right? This double angle formula for sine. Yeah, that's exactly it. So we're pretty much done.